For this question, we want to sketch the graph of the following function and identify all the properties that apply. Our function is f of x equals square root x. I'm going to graph this function using the plotting points method. And typically, I'll choose a standard set of points for my x's to then find the y values. The standard set that I typically choose is -2, -1, 0, 1, and 2. But because our function is f of x equals square root x, I know that the square root is only defined for non-negative values of x. So instead of choosing -2 and -1, I'm going to start choosing at 0 and 1, and then I would usually choose 2, but I want some nice ordered pairs to graph, so instead of choosing a value of 2, I'm going to choose a value of 4, since the square root of 4 is 2, and then I'll choose a value of 9, since the square root of 9 is 3. So this makes it a little easier for me to plot points in my graph. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. I have some ordered pairs. I have 0, 0, 1, 1, 4, 2, and 9, 3. These points naturally connect to each other. And I want you to notice at this point of 0, 0, my line comes to a stop, and that's because the square root function is undefined for all of these negative x values. So my graph comes to a stop at that point. Let's take a look at the properties. The first property says the function is an even function. And for you to have an even function, you need to have y-axis symmetry. So you need to have a mirror image over the y-axis. So whatever you have to the right of the y-axis, you also need to have to the left. If we take a look at our quadrant 1, comparing it to quadrant 2, you can see that we don't have a mirror image over the y-axis, so we would not select this property. Okay, the next property says the function is increasing on the interval from -infinity to infinity. And this function is not defined on the interval from -infinity to infinity. This function is only defined from 0 to infinity. So even though this function is increasing the whole time, it's only increasing from 0 to infinity. And so we would not select this property. As I mentioned just a moment ago, the function is defined from 0 to infinity. So this next property that says the domain is from -infinity to infinity is also not true. So our actual domain for this function is from 0 to infinity. So we would not select this property. The next one says the function's an odd function, and that means that we have origin symmetry. And for you to have origin symmetry, you need opposite quadrants to have a mirror image. And so we would look in quadrant 1 and compare that to quadrant 3, and you can see that you don't have a mirror image. So we would not select this property. And the next one says the function is a linear function. This is not linear. Linear would be y equals mx plus b, and focusing on the x part, that would need to be to the first power. A square root of x is the same thing as x to the 1/2 power, so this is not a linear function. We would categorize this as a radical or root function. The next property says the range is from negative infinity to infinity. If I take a look at my ruler and hold it horizontally and go from bottom to top, you can see that I have no y values along this bottom section, and the range doesn't start until you get to 0. So our range for this one would go from 0 to infinity, and we would not select this property. Since we've not selected any of the above properties, we would select this last one, that none of the properties apply. On this question, we're given f of x equals this piecewise function. You can see by the curly braces, we have two different equations. One equation is the absolute value of x, and the other equation is 1 over x. And then we're given some guidance here on when to use each one of these equations. In this one, it says if x is less than or equal to 0, we're to use the absolute value equation. If x is greater than 0, we're going to use this reciprocal function 1 over x. We're given a few parts here to work out. We want to find part A, which is f of negative 2. In f of negative 2, we're given that x is negative 2. And since negative 2 is less than or equal to 0, I'm going to use the absolute value equation to work this example out. The absolute value of negative 2 is positive 2. So f of negative 2 is 2. In part B, we have f of negative 5. X is negative 5. And since negative 5 is less than or equal to 0, I'll use the absolute value equation to evaluate this function. That's absolute value of negative 5, which is positive 5. So f of negative 5 is 5. Then finally, we have part C, which is to find f of 3. X is equal to 3. And since 3 is greater than 0, we'll use the reciprocal function to evaluate. 1 over 3, and that's 1/3. f of 3 is 1/3. For this question, we want to give the rule that describes the piecewise defined function in this graph. So we have a picture here of a graph, and we want to find the rule or the equation that matches this particular graph. So I'm going to start by figuring out the conditions on each equation. So because I have two pieces of the graph, I'm going to have two equations. So it's going to be f of x equals an equation with some conditions, a second equation with some conditions. So we'll figure out the conditions part first. So by looking at this first line, I can see that it starts at an x value of negative 8, and it stops at an x value of, looks like, negative 1. So the conditions for that first equation are going to be that your x, I'm going to write it a little bit bigger here, your x is going to be in between negative 8 and negative 1. So since the line started at an x value of 8 and stopped at an x value of negative 1, we're going to use that line whenever x is in between negative 8 and negative 1. You'll notice that I also put brackets on, not brackets, I put the lines underneath the inequality symbol to indicate that the endpoints will also be used for this line. So I did that because this endpoint has a filled in dot and this endpoint has a filled in dot. So the endpoints will be included, and that's why we have these lines here. For the other line, we'll do this one in purple. For the other line, I can see that this line starts at -1, and because of the arrow, continues on to infinity. So the conditions will be that x needs to be greater than -1. I didn't put the line underneath the inequality symbol because the end of that line is with an open circle. So that's how we get the conditions. Now we want to find the actual equation that matches these conditions. So I'll start with the easier one. So this line here that I'm highlighting is a horizontal line. Sorry, it's not highlighting. So the line that I've highlighted is a horizontal line. The equation of a horizontal line is y equals some value. And for this example, all of the y values are the same, which is a y value of 4. So the equation of that line is just 4. The horizontal line, 4. The other line is a little bit harder to find, but it is a straight line, and we do have 2 points on that line. And so we're going to be able to calculate the slope and to find the y-intercept. So this point right here is the point -1, 3, and the other point is -8, 4. So I'll use the equation or the formula y2 minus y1 over x2 minus x1. I'll let one point be x1, y1, and the other point be x2, y2. That's going to give me y2, which is 3, minus y1, which is -4, over x2. x2 is -1, minus x1 being -8. That's 3 plus 4 over -1 plus 8. That's 7 over 7, which is 1. So we have the slope of the line being 1. And then I can use point slope form, y minus y1 equals m times x minus x1. I'm going to use the slope in either of the 2 points. I usually try to use points with smaller numbers because I can do the math in my head a little easier. So I have y minus y1, so that's the 3, equals the slope of 1 times x minus the x value is -1 for that point. That's y minus 3 equals x plus 1, and I would add 3 to both sides. That gives me the equation y equals x plus 4. So the equation is x plus 4. So this is going to give me the piecewise defined function for this graph. So our function is this right here. F of x will be x plus 4 when x is from -8 to -1, including -8 and -1. And f of x will be 4 whenever x is greater than -1. For this question, we want to find the rule that describes the piecewise defined function. So we have a picture which is representing a piecewise defined function, and we want to find the rule or the equation that matches this picture. So looking at this, I have two pieces of the picture. I have this linear piece. It's going to be a straight line, and then I also have this curved piece, which looks like a parabola. So I'm going to have a function, a piecewise defined function that has two equations, and then along with those equations, we'll have some conditions. So let's start with the conditions. So on the linear piece, I can see that my x starts, that piece starts at -7, and that piece stops at -2. So for the linear piece, I am going to have the condition that x needs to be in between -7 and -2. And as I look at this endpoint here, that's a filled in dot. So I'm going to put an equal to on the -7. However, there is an open circle on this end, so I don't want to include the -2. Let me make a correction here. I forgot to put the inequality symbol. So for this one, I will not put the equal to under that inequality symbol so that that endpoint of the line is not included. Then for the other piece of the line, which is the parabola piece, you can see that that piece starts at -2 and then stops when I get to 3. So for this one, x will be in between -2 and 3. Looking at one end, we have the open circle, and on the other end, we have the closed circle. So on the closed circle, I want to put the equal to, and on the open circle, I don't put the equal to. Then we want to find the equation. And by the looks of this equation, it looks like my basic graph of a parabola, which is the x squared function. You can see that it's got its vertex at the origin, so it hasn't even been shifted left or right or anything. So the parabola equation is x squared, the basic function of x squared. And then for the linear function, we have 2 points on the line, and we can find the slope and then the equation of the line. So the 2 points on the line for this one are -7, -6, and -2, 4. I'll let one point be x1, y1, the other one x2, y2. I can calculate the slope using the formula y2 minus y1 over x2 minus x1. So substituting into that formula, I have 4 minus -6 over -2 minus -7. If I simplify, that's 4 plus 6 over -2 plus 7. That's 10 over 5, which is 2. So I have a slope of 2. And I'll choose one of these points. I usually like to choose the point with the smaller numbers. And I'll use point slope form to find the equation of the line. So that's y minus y1 equals m times x minus x1. So y minus 4 equals 2 times x minus -2. It's y minus 4 equals 2 times x plus 2. Then I'll distribute the slope of 2 to give me 2x plus 4. I'll add 4 to both sides, giving me the equation y equals 2x plus 8. So now we found the equation of the line to be y equals 2x plus 8. So we'll use 2x plus 8. So we found our rule or equation for the piecewise function, and that is that it's 2x plus 8 for x's that are from -7 to -2, and x squared when x is from -2 to 3. Thank you for checking out my videos. Have a great day.